Hello everyone and welcome to Math with Corey. Today we're going to be differentiating exponential functions with base e, and as long as we know the formula, it should be fairly simple. So let's begin. Okay, so if I look at my three examples here, okay, again, exponential with base e, okay? So let's come up with a general formula that we can apply and use for each of these examples, okay? So if I wanted to take the derivative with respect to u of e to the u, okay, that would be, well, I'm going to use the chain rule. It's going to be e to the u times u prime, okay? So if we look at number one, okay, which I will rewrite here, okay, it's e to the 1 over x. And I can write e to the 1 over x as this, e to the x to the negative 1. So if I wanted to bring that x to the numerator, I could just say that it's x to the negative 1, okay? And this will really just help me find out what u prime is, okay? So again, I'm trying to find the derivative, so y prime equals, well, it's e to the u. Well, e to the u is e to the 1 over x, okay? So what is u? U is 1 over x, or as we rewrote it, okay, x to the negative 1. Okay, so the derivative of this, okay, I'm going to bring this number to the front, make it the coefficient, and subtract 1 from negative 1. So negative 1 minus 1, negative 2. So I can write this as negative 1 over x squared, okay, because I bring this x to the denominator. I could say that it's negative, the negative out in front, 1 over x squared. Okay, great. So now I have e to the u. Now I want to multiply it by u prime, which again is negative 1 over x squared. So y prime, okay, I want to bring this negative to the front, is, okay, I can write it as this, negative e 1 over x squared. And that's your answer for number one. Let's take a look at number two. All right, so for number two, I have y equals e to the 5x plus 3. Okay, so same idea, right? Y prime equals, well, e to the u. That is going to be e to the 5x plus 3. Okay, so again, u is 5x plus 3. So the derivative of that is going to be, well, 5. Okay, so times 5. Okay, and to write it maybe a little more neat, bring that 5 out in front, and you can express your answer like this, right? So that's the derivative. Let's look at number three. Okay, so if we look at number three, it's y equals e to the x cubed plus 8x, okay? So again, we're gonna wanna use the same formula, okay? So y prime equals, okay, e to the u, well, that's going to be e to the x cubed plus 8x times u prime. Well, u is x cubed plus 8x. U prime equals, that is going to be 3x squared plus 8. Okay, so I just took the derivative of u to get u prime, which is 3x squared plus 8. So I'm going to take e to the u and multiply that by u prime, 3x squared plus 8. Okay, and I can distribute, okay, into the parentheses, or I can just leave my answer as such, okay? So by this formula, using this formula, we were able to solve our three example problems, okay? And if you'd like to try this here, this is a added bonus. I'll give you the answer soon later, so pause the video if you'd like to try. Okay, so here's the answer. So what you have to do is use the product rule and kind of use that formula that we had with the chain rule. Okay, so what I would be doing is the first times the derivative of the second. Okay, so again, if we look at the derivative with respect to u of e to the u, that is going to be e to the u times u prime. So I have e to the u times u prime. Well, derivative of 5x is just 5. So 5x squared e to the 5x plus the second times the derivative of the first. So it's going to be 2x e to the 5x. And if you'd like, you could take out an e to the 5x and an x, and you'd be left with this, okay? If you guys have any questions, please leave it in the comments below. Thank you for watching.